In this paper, we present our approximation to ambient occlusion for trees and grass. Our approximation is based on statistical reasoning for a simple configuration of small random objects. This reasoning leads to the following approach in practice. First, we enclose the object with a bounding ellipsoid. Then, for a point x on the tree, which we want to shade, which has normal n, we compute the volume of a cap defined by the plane defined by x and n. Our ambient visibility approximation uses the volume v sub cap as well as a factor f to account for off-axis effects. A user-controllable parameter alpha and density rho are also used in the equation. We first visualize the ambient visibility quantity computed with this approximation as a grayscale image. We next show the fully shaded model. Evidently, using just the ambient term results in a flat image. The most closely related previous work is the model developed by Reeves and Blau. As we can see, their approach does not take into account normal variation or off-axis effects. As a result, the images are much smoother and lack details as can be seen here. In this still image, we show a comparison of our ambient occlusion approach, ambient only, and the Reeves-Blau approach. Our approach is fast enough to treat moving objects such as grass. In this sequence, we show a scene with moving grass and a tree. We tested our approach on a generated ecosystem scene. We first show the fly-through using our ambient occlusion approximation. Our method provides plausible sky dome effects, in particular with convincing details in the tree leaves and in the grass. We next show ambient only for the same scene, which results in a very flat-looking image. The approximation of Reeves and Blau is smooth, but lacks the detail of our approach, especially in the trees and the leaves. We show next a comparison between ambient only and our method, showing how our approach gives a visually rich result. We show here a comparison of our approach with Reeves and Blau. We clearly have more detailed and visually interesting shadows in the trees and leaves, as can be seen in the fly-through. The comparison of the two trees in the final still clearly shows the improvement of our approach.